Hi guys, this is Mrs. Geiger, and I'm going to explain to you why some ionic substances can dissolve in water and some cannot. Most of this has to do with water's polarity. So water, because it's polar, we know that it has one side that is positively charged and one side that is negatively charged. Oh, I'm in the pen mode. Let me just erase that pen quickly, and let me go here. All right, so if I was to take this water molecule, let's say, and you can see it can go in 3 dimensions there, and so I'm going to go ahead and rotate it towards this way. I'm going to rotate it this way. All right. Now, the reason why is that this is supposed to represent a positive cation. So I'm going to go ahead and label my ions there. So, oops, my bad. All right. So I'm going to go ahead and label my ions there. So I have here positive ions. So this, I'm going to just give it a little plus sign in there. And here the same thing. There are my negative anions. So since we know that water molecules have a negative side and a positive side, you need to know that the oxygen side is the negative side of the water molecule. So that oxygen side of that water molecule is going to go ahead and it is going to be attracted to any positive ion. Now don't forget that positive ions are called cations. And the force of attraction there between the negative part of the water molecule and the positive cation there is going to happen anytime you put a salt in water. So when this happens, the water molecule is going to pull on the ion. Now, if the force of attraction between this positive ion here and this negative ion and this other negative ion here is greater. So if the force of attraction between the water is greater than the force of attraction between the positive ions and these negative ions, then the water molecule is going to be able to dissolve the salt and pull it apart. So the water molecule is going to grab onto this positive ion and it is going to pull the positive ion away, and therefore the salt will become dissolved. Now, this other water molecule here will likely be attracted, this negative side be attracted, and surround these ions. So the positive ion there will be surrounded in all 3 dimensions with water molecules. At the same time, this water molecule perhaps is attracted to an ion here. So notice that the positive hydrogen side of the water molecule is attracted to the negative ion. Now, if the force of attraction between the water molecule is greater to the ion is greater than the force of attraction between the ions, between the negative and positive of the ions, then the water will be able to dissolve this salt, and this salt will be soluble. It will dissolve into the water and it will be surrounded. So this positive ion, which side of the water molecule will be attracted to that positive ion? The hydrogen side or the oxygen side? That's right, you got it. It's the oxygen side, just like how in the positive ion up here, that negative oxygen side of the water molecule is going to attract. It's going to pull. And since the force of attraction between the water and the ions is greater than the force of attraction between each ion, the water molecules will be able to completely surround these salt ions and dissolve. Now, some salts, on the other hand, do not dissolve. Some salts have such a strong force of attraction between the positive ions and the negative ions that not even water can pull them apart. I'm going to go ahead and modify this picture. I'm going to make my negatives bigger to model that they have a larger negative charge. And I'm going to make my positives bigger. And I'm going to go ahead and add into them an extra charge. So my negatives, I'm going to make this one 2 minus, I'm going to make this one 2 minus, I'm going to make this 2 plus, and I'm going to make this 2 plus. So the force of attraction is now greater between those ions. Now, when this salt goes into the water molecules are still attracted to the ions, but they pull on them and are unable to pull these ions apart from each other. So even though the water molecules are attracted, as they pull, they're not able to pull those ions apart. And that is what is known to be an insoluble salt, an ionic substance that is being pulled on. It's in water, and the water molecules are pulling on the salt, but they are unable to pull it apart because the force of attraction between the salts, the force of attraction here between the positive and that negative, the force of attraction between the positive and the negative here, and the positive and the negative here, and the positive and the negative here, and the positive and the negative here, that I'm highlighting is greater than the water's attraction here. So they're unable to pull them apart. This is how we get insoluble salts. So hopefully this was useful for you, and it helped you understand how Table F has one side on the left where salts are typically soluble, and the other side on the right where salts are typically insoluble.